Okay, hello everybody, welcome back to another video. Today we're going to a different subject, a subject that's never been done before on this channel. We are doing ionic equations as a part of the Aqa GCSE chemistry SPEC. So, ionic equations. Personally, this chapter is one of the most confusing chapters for me, and I've seen students struggle on this a lot. So, ionic equations, what do we know about them? Ionic. What does this mean? It means a non-metal bonded to a metal. Okay, this is fundamental. In an ionic equation, we have some fundamental rules. One of our rules is, we'll look at it through a question, okay? BaCl2 diatomic, chlorine is diatomic, aqueous, plus Na sodium sulfate in its aqueous form makes BaSO4 solid form plus 2 sodium chloride, 2NaCl in its aqueous form. Right, so first rule is we have to break down this substance. Okay, it's balanced. Okay, we can see that there's one barium here, one barium here, 2 chlorines, 2 sodiums, and 1 sulfate. Okay, now we have to break down the equation. To break down the equation, we can only break down the substances that are in aqueous form. The ones that are in solid form remain the same. Let me show you. This is going to be Ba. Let me write that better. Ba plus Cl plus Na2 plus SO4 equals to barium sulfate is a solid, henceforth it stays the same. BaSO4, okay, and then plus 2Na, and I'll just write down here plus 2Cl. Okay, now what we have to do is we have to add their charges. Now, if we get out our periodic table, we can see that Ba is where's Ba? Ba, barium, is part of group 2. Henceforth, it has a 2 plus, right? Now, you wouldn't be expected to memorize the location of barium. Okay, we can take chlorine. We know that chlorine is in group 7 and it has a charge of -1. Group 7 electrons in the outer shell, easier to gain 1 than to lose 7. Henceforth, it has a charge of -1 . So if there's 2 chlorines, then there have to be 2 bromines to balance this. Or the bromine has a +2 charge to balance the -2 charge that the chlorine is giving. So it's going to be Ba2 plus Cl2 minus, because there's 2, it multiplies and it becomes 2 minus, plus same thing for the sodium sulfate. What happens here is you have to memorize the valencies. For example, for sulfate, it's SO4 2 minus. However, if you don't know it, you can look at sodium, Na. Now we go to the periodic table. Na. Sodium, group 1. It is part of group 1, so it has a 1 plus charge, and there is 2 sodiums, so Na2 plus, the charge is multiplied, so it becomes 2 plus. Henceforth, we can figure out to balance this. The sulfate has to have a charge of 2 minus. Okay. Now, moving on. I will actually write down here because I do not think we have space. We have BaSO4, which remains the same, plus 2Na plus 2Cl. Na we see here, 2Na gives plus 2Cl minus. Okay, easy enough. Now we have to go through something called spectator ions. These are parts of the equation or substances that remain the same before and after the chemical reaction. For example, let's see. We have, let me check. Yeah, okay. So what happens here is that you have to cancel the chlorine and chlorine. So the chlorine over here and the chlorine over here. So because they are the exact same, there's two chlorines, two chlorine minus, they cancel. Same thing with the sodium. 2Na plus, 2 sodium with the plus charge. Same thing, so they cancel. Now what we're left in with barium and sodium, with barium and sulfate. So okay. Sorry, I was checking the name of SO4, which is sulfate. So we have Ba2 plus SO4 2 minus equals to BaSO4, and that should be our final answer. What you might also want to do is change this into aqueous, and this is a solid because we know from the question. Yeah, and that's going to be our answer. So to go through this once again, let me take you to another question. This time we write smaller. Okay, this one is much more complex in terms of how it looks, but we will try. Lead, nitrogen oxide, NO3, 2 in its aqueous form, plus potassium iodide, Ki in its aqueous form makes lead iodide, PbI2 solid. And this is the question, by the way. This is how they're going to give it to you in the actual exam. I'm reading it off a question. Plus 2 potassium nitrogen oxide. Not sure how to say this. So okay, now to split it up. We have Pb plus I'm thinking about how to write this. Okay, I understand. So now if we split this one up, what we get is lead, and then we also have this 2, which makes the equation kind of awkward. So what happens is this 2, it's the same thing as the coefficient. So what we're going to write is 2NO3. Because if you think about it, this 2 just means everything times 2, right? The N times 2, the oxygen times 2. So that's it. And this 2 means the same thing. This times 2, this times 2. So nothing really needs to be changed here. Now we can move on to our 2Ki. This just means 2K plus 2I, because remember, equals to PB plus I. Oh, sorry, that's solid. Why would I change that? PBI2 in a solid form, hence we don't change it. Plus, now this one we can change. 2K plus 2NO3 in its aqueous form. Now I can add the charges. Lead, or PB, is PB. Where is PB lead? Lead. It's a part of group 4. So we just have to memorize the valencies again. So NO3's valency is, I think it's NO3 minus. I will just check that. NO3 valency. Valencies are something that needs to be memorized. Yes, it is NO3 minus. So we have the 2 multiplies with the minus, so it's going to be 2 plus here. Here we know that potassium is a +1 and iodine is a +1, so this is just going to be plus, this is just going to be minus. PbI2 stays the same. 2K means plus, we just checked that, and NO3 is minus. Perfect. Now we can cancel out our spectator ions, which are the 2NO3, 2NO3. Lead changes. Potassium does not change, we can cancel out that. And iodine changes. So what we are left with is PB2 plus in its aqueous form plus 2I minus in its aqueous form to give lead iodide in its solid form. And that is our answer. Yeah, that's our answer. To go over the rules again, we can only split the ones with the aqueous. We do not split the ones with solid in it. Okay. Furthermore, we have to check the valencies. We can check the valencies either using one that we already know, which is common, like the Cl2 minus, and balance that out. We need the 2 plus charge from the barium, henceforth barium is 2 plus. Same thing over here, and we cancel out the spectator ions to get our ionic equation. So you can also make this into half equations, but you don't need to. For example, we'll just do like lead 2 plus gives us to get lead. So what we have to do is just add 2 electrons to it. Electrons are negative and we need 2 of them, so 2e minus to get the normal form. Same thing with the iodine. 2i minus so I to get I2, so we add this plus 2e minus yeah, plus 2e minus, no, plus e minus, I'll just check this. Okay. Right. So Pb2 plus 2e minus gives us lead Pb. This one is fine. 2i minus I2 plus it is 2e minus. Okay. That's it for today's video, everyone. I hope you enjoyed, and come back next time. Thank you.